Nadie ve los videos de todas maneras. Okay, so let's share this part. Let's move right here. Let's move to the previous problem. Yeah, Yeah. Remember we began this one? Yeah. So it's a find the slope of the tangent line to the graph of f equals pi. So what we have to do is that we did the derivative of this, right? And then we evaluate in pi, that's the slope in this point. And then this function in pi was 2, so we found that thing. So let me just put it right here. Vamos a empezar. Yeah, f of x equals cosine of 2x plus e to the sine x. Yeah, and then this is okay. This is a slope of tangent line, so we have y minus y0 equals mx minus x0 when x0 is pi. Vamos a ponerlo aquí. Eso era lo que contestamos ayer. So, x0 pi means that y is f of pi, right? Because this is the function, so this is the coordinate. So for this coordinate, the y is this one, so what era un 2, right? Es lo que sacamos aquí. Was a 2. And, bueno, el punto era pi, 2. This era el point, right? Y0. Vamos a poner aquí y0. So this is x0, y0 equals pi, 2. So the only we have to do is substitute this thing right here and get the 2. Then m was f prime in pi, correct? That was m. So hicimos f prime of x, the derivative of this thing, so it's negative sine of 2x times 2 plus, so yeah, derivative of sine cosine, derivative of 2x is 2. And this was e to the sine, same function, times cosine x. Once we put f of pi, I guess we found was a -1, right? So with this solution, we have y minus y0, 2 equals -1 times x minus pi. And that was the equation, correct? Then in the next question, right? In the next question, we did b. Let k be a function defined by the composition of this thing. Yeah. Okay. And, well, we have to find the value of k. So k was h of f of x, correct? And this is, well, what we have to find is k prime of pi. Let me just show you this one. Yeah. Then stop share right here. This is what we have to do. So the only we have to do is, okay, this is k of x. So k prime was h prime of f of x times f prime of x. So it's just the chain rule. Once we have this one, this is k prime of pi was h prime of f of pi, correct? Times f prime of pi. Now, f prime of pi was here, it's -1. F of pi is this one, 2. So we had to do, this is h prime of 2 times -1, right? Yeah. And h prime of 2, remember, there was a function here at the beginning of the problem, right here. This was the graph of h. This is the graph of h. So we have to find the slope of the tangent line in 2, right there. Okay? Now, the slope of the tangent line is the slope of this thing. So this is rise over run, so -1/3. So this was simply -1/3 times -1. So k prime of pi was 1/3 positive, correct? 1/3 positive. 1/3. Okay, so that's what we did yesterday. So you see, not big math, just concepts, right? Now let's try the next question. The next question was, let K, no, the next is, let M be a function defined by mx equals that. Just get another board, all right? So I have here m of x equals g of negative 2x times h of x, correct? And we have to find f m prime into. So let me just stop share right here. So this is the new problem. So the new function is defined by this composition and this product. So we have to find a prime of 2. So again, the same. M prime of x is the derivative of this product. So it's derivative of this times this. So it's g prime negative 2x derivative of the inner negative 2 times h of x plus g of negative 2x times h prime of x. Now, sorting this a little bit, this is going to be negative 2 g prime of negative 2x hx plus g negative 2x h prime of x. So the only thing we have to do now is evaluate in 2. So it's negative 2 g prime, here is a 4, negative 2 times 2 is negative 4, h prime of 2 plus g of negative 4 h prime of 2, correct? So here is 2 times 2, 4, negative 4, correct? Now, we know h of 2 in h prime of 2. So from the same graph, if we check that one, so right here, so here is h. h of 2 is, oops, coming like 2/3, right? 1/3, 2/3, 3/3. And the slope is negative 1/3. So we can put those values right here. Let me just go back. This is negative 2/3. And this is negative 1/3. Now the only have to do is put here the value of g prime of 4 and g of negative 4. And I have to check what is that. So let me see. Right here, I see this table, you see? You see g of x and g prime of x, and I need g negative 4. Here are the values. G of negative 4 is 5, g prime of negative 4 is negative 1. So here I put a negative 1 and a 5, correct? So this is what I have to do. This is, let me just put this one right here. Oh. So let me just look for the problem here. Yep. Here is g prime of 4, g prime of negative 4 is negative 1, and g of negative 4 is 5. Then the only you have to do is perform these operations, right? And, well, that's basic algebra. So negative times a negative, positive times a negative, so is 4/3 negative plus, well, minus 5/3. And this is a simple math problem, so these are negative 9/3, negative 3. That's my answer. Okay, so this is calculus. Yes, this is calculus, not really this one, but this one is just evaluation, right? Okay, so see that we are not doing any complex math here, only applying the rules, correct? Chain rule, product rule, and then evaluating. No questions here? Pretty easy, right? Okay, last problem. In the last problem, in the last question, yeah, we have, is there a number z in the closed interval negative 5, negative 3, such that g prime of c equals negative 4? Justify your answer. Okay, Now, let me just put right here. Let me just try to fit right here in this portion. So on negative 5,3, negative 3, this is g prime of c equals negative 4. Let me just put right here. Yeah, this one. This is what we have to show now. Okay, now we have to check what is g. G, let me see. Let me just go back to the problem now. So again, the function g is right here, right? This g is a differentiable function, correct? And you have g and g prime, correct? Here. So a differentiable function is continuous, and then we have to check this, okay? They want to know if there is a value for which this is negative 4. So how can we know that? This is, well, what we're going to do is the mean value theorem, the MVT. The MVT says that g prime of c can be, in this case, g of negative 5 minus g of negative 3 over negative 5 minus negative 3. So the slope between these 2 points of the function may be possibly the derivative. Well, it's going to be the derivative at one point that is between negative 5 and 3. So 4, negative 5 less than c less than negative 3. Okay, so this is the MVT, the mean value theorem. So the only we have to do is this one. How much is this? It's okay. So that's algebra 1. So g prime of negative 5 minus g of negative 3 over negative 5 plus 3 is going to be, well, on the table we find that g of negative 5 is 10, g of negative 3 is 2 over negative 2, correct? Now, if we do these numbers, 10 minus 2 is 8, and over 2, so this is negative 4, correct? So, yes, because g of x is differentiable on negative 5, negative 3, right? There's a point or a number c between negative 5, negative 3, such that g prime of c equals negative 4. So that's the answer, really. So how do you solve this one? With the mean value theorem. This is the mean value theorem. The slope of the secant between negative 5 and negative 3 is the derivative of a point, the value of the derivative of a point between them. Then we compute this slope. We find that it's negative 4. So exactly match this one, g prime of c negative 4. So because g of x is differentiable on this interval, there is a point c between these two, such that g prime of c is negative 4. Okay, so you can see all the work we did for this problem, right? All the problem, all the work we did for this problem. Now, check. Not cosines, no sines, no big derivatives, only concepts. These problems are very common in the AP test, okay? So I don't know if this is going to be one of them. Okie dokie. Questions? Everything fine? Well, let me just go here and check the next problem. The 2017. Yep. This is okay. Here is. This new problem is a no calculator allowed. No, is a calculator allowed, right? Was released in 2017. Yeah. And let's see what we can do with this. It's okay. This when a certain grocery store opens, it has 50 pounds of bananas on a display table. Customers remove bananas from the display table at the rate model by ft equals that function, okay? For 0 to 12, where ft is measured in pounds per hour and t is the number of hours after the store is open. After the store has been open for 3 hours, store employees add bananas to the display table at the rate model by the new function g of t. Again, g of t is measured in pounds per hour, and t is the number of hours after the store is open, correct? Now, remember this. After you read this one, you see that pretty much all these problems are the same way. A function adds, a function subtracts. This is a rate, this is a rate. So it's important that you state the rate. So in this case, here, yeah, you have f of t, right? And this is going to be the derivative of I'm going to put BO, see, bananas out or remove, or BR, also bananas remove, right? Yeah, DT. So let me just show you my board. So this is what I have. So FT is dVdt because these are pounds, hours. So those are the units, correct? And the function g of t is going to be dB. This is remove. This is, well, I don't want P placed dt. So again, our pounds of bananas over hour. So dimensional analysis is important here. So F and G are rate of changes, derivatives of function. These are the pounds of bananas are removed by customers. These are the pounds of bananas the employees replace. This happens from 0 to 12, and this happens from 3 to 12. Correct? Yes, from 3 to 12. Okay, these are my hypotheses. So the first question, right, is this: how many pounds of bananas are removed from the display during the first 2 hours the store is open? Okay, how many pounds of bananas are removed from the display during the first 2 hours the store is open? Okay, now remember these are the bananas removed. So you want to know this at t equals 2. So let's put here A. So I'm going to put my calculus here. Well, I'm going to use my this one. So this is f of t is dvr over dt. So I need br of 2 is what I need. How many bananas I at br2? This is okay. How do you solve this? Well, you have to remove the derivative. So we have to do integral dvr dt times dt equals the integral of f of t dt. Now, what integral we have to do? This is, well, from 0 to 2 is the interval since the store open, 2 hours later. And then this is going to be br of 0 to br of 2. So b of 0 is the amount of bananas on the display at the beginning of the day. And br of 2 is the bananas on the display after 2 hours. So simply, if we continue, this is going to be br of 2 minus br of 0. So this is the change in the number of bananas in the display is going to be the integral 0 to ft dt, correct? Now, this is going to be solved in the calculator, correct? So, in the calculator, I'm going to do this. So I'm going to open a new document, I don't save. And then I put, let me just calculate, right? Remember, I'm going to define the function. So I'm going to define f of x, right? Oh, sorry. This one, this is f of x, right? Equals, no, this x, sorry, this x, okay? Okay, is going to be, let me just copy this one, is a 10 plus 0.8 times x, right? No, times x, times x, times the sign, parentheses, x cubed, divided by 100, yeah. So that's my function. So yes, let me check. Yes, I don't want to make a mistake as in the previous problem. Yeah, sine x cubed, correct. So I press enter. So this function is in the memory. Now I'm going to define the other functions. Is define, yeah, g of t or g of x equals, and then I'm going to put the other function is 3 plus 2.4 times the natural log of t squared, yeah, plus 2t. Well, this has to be x, sorry. X plus 2x, correct? Yeah. So I press enter, and that's my function. Let me just check with the graph. Yeah. Yeah, it's 0.8x sine, yes, correct. G of x is also correct. Okay. Now, what I have to do? Well, I have to do the integral of f. So the only I have to do is menu, calculus, integral, and then I have to integrate from 0 to 2, right? And I have to put here only f of x dx, correct? So this is the only thing I have to do. I have to integrate this function, same as I put here in my paper. So it's the integral from 0 to 2 ft dt. So I do that. Let me just go back again, right here. And well, once it's there, press enter as 20.05. So this is going to be 20 bananas. Okay. So obviously this is very small to count as a single banana. So we are going to stop in 20. So this is going to be the number of bananas. How many pounds of bananas are removed from the display during the first 2 hours? 20, well, no bananas, pounds. Correct? 20 pounds. Okay, any question here? Any question about these two functions? Any question how we solve for BR in 2 using the integral to cancel the derivative? And this is the number of bananas removed, B of 2 minus B on 0. And this is the integral we have to compute. Okay, no problems? Just put here.
No.
Okay, like that. Next question. Next question here. So find f prime of 7. Using correct units, explain the meaning of f prime of 7 in the context of the problem. It's okay. So it's just f of t is dvr over dt. Let me just write this one in my paper, right? F prime of 7, you have f prime of 7. Okay, so stop share. This one, this is the next thing we have to answer. Ft is the derivative of something, the number of pounds you are removed, respect the time, and we want f prime of 7. So these units, remember, are pounds per hour, right? And f prime of t is going to have what units? Because is v br sec squared dt squared. So it's pounds over hour squared, correct? No problem with this. So f of t is the second derivative of the number of bananas respect the time. So it's pounds of bananas per hour square. Is this reminding you something? Units like this? Okay. Now let's see, how can we get f prime of 7? This is okay. F prime of 7 is the derivative respect x. And technically we have to do 10 plus 0.8 t. Well, this is t, really. This is t. Sine of t cubed over 100, correct? Evaluated in t equals 3. Oh, 7, I mean. T equals 7. So we have to get this derivative. Okay, don't worry. So we use the calculator for this. So this is really d of f of t dt at t equals 7. So that's why I wrote this function in the memory. So I don't have to type this again. So just here, and then I'm going to take here menu, calculus, derivative at a point, and then this is variable x, value, okay, what value we want? 7. I'm going to put here 7. First derivative, I press OK, and then, well, what function I need? Well, it's going to be f of x, correct? F of x at x equals 7, press enter, and it's going to be negative 8.1195 pounds over hour square. So let me just show the board right here. So this is what we have. This is my answer. Okay, ingenieros. Okay, engineers. How do you interpret this one? What is the meaning of the first derivative at 7?
Pues el slope, ¿no?
Ya, pero acuérdate. Read the problem. Dice, es slope, pero dice, explain the meaning in the context of the problem. So, is slope, correcto. But in the problem te dicen que son bananas, correct? So, how do you explain this with bananas? No idea. Fíjense bien en estas unidades. ¿No les recuerda algo? Is this reminding you something? What thing changed with the square of the time?
The acceleration, the velocity.
Correcto. What is the acceleration?
Pues ese número.
No. Explícame, what is the acceleration? What is the acceleration give you? An acceleration, not this acceleration, sino any acceleration. Suppose you want to explain to a 5th grader, what is the acceleration? What you say?
The change of velocity.
Correct. Change the velocity in with the time, correct?
Yeah.
Yes, okay. So this is the rate of change of what? Now go to the problem. The velocity is change of distance respect the time. So distance advance in the time, per time. This is the rate of change. So the rate the bananas are removed from the counter, correct? Esta. This is the rate the bananas are removed from the counter. So this what is going to be? It's an acceleration. You told me acceleration is the change of the velocity. Is the rate of change of the rate of change, correct?
Mm-hmm.
So a ver, somebody can explain this now using your own words.
Leo.
Libras de bananas por hora.
¿Eu? ¿De qué? What?
Libras de banana por hora.
Por hora. A ver. Fíjate bien. Aquí hay un square. So, este es el rate of change del rate of change. ¿Se fijan? This is the rate of change of this rate of change. ¿Cómo lo explicarían?
¿Y acceleration? No, ¿verdad?
Sí, es una acceleration. Pero en este caso no tienes distancia sobre tiempo, tienes libras de bananas por tiempo. ¿Cómo lo explicarías? You see, the explanation seems more difficult than the math.
Like the rate of change is decreasing?
Mm-hmm. So, the rate at t equals 7, the rate at which, the clients, the customers are removing bananas from the counter is decreasing, correct?
Mm-hmm.
Every time you have a negative is decreasing. So, the rate of change at which the customers remove bananas from the counter is decreasing at t equals 7, correct? That's the explanation. The rate of change at which the customers remove bananas from the counter is decreasing. So they are removing less bananas, correct? Well, any question? You see the problem? Check. Yeah, scary. A little bit. Okay. Let me just go to the next question. Okay. C is the number of pounds of bananas. Is the number of pounds of bananas on the display table increasing or decreasing at time t equals 5? Give a reason for your answer. Okay. So is the number of bananas, how can you know a function is increasing or decreasing?
With the acceleration and the velocity.
With the velocity, correcto, muy bien. Very good. Yeah. Is the number of pounds of bananas increasing or decreasing? So B of R, the display is increasing or decreasing. But how do you get the number of bananas on the display at t equals 5? How do you find that? So what function you use? You use F, you use G, or you use both? Fíjense bien. 5 is between these two intervals, you see? 5 is here, 5 is here, and 5 is here also. So what do you think? How do you find the number of bananas in the counter? Bananas como? Nothing? So is everybody catching the question? So, is the number of pounds of bananas on display increasing or decreasing at time equals 5? By this time, yeah, you have to use both. Why? Because this is the rate the clients are removing bananas from the counter, and this is the rate employees are replacing bananas on the counter. So the total number of bananas is related with these two functions, correct? So you have to put them together. Ahora, you add them or you subtract them? Hmm? You add them or you subtract them?
You add them, no?
A ver, Areli, you add them or you subtract them? Multiply them, of course, is not logical. So, let me just go to the board here. So I have to put the number of bananas in the counter, MB. So I have to put here F of T and G of T. You told me I have to use both, correct? So this is N sub B of T. Number of bananas in the counter, okay? But I have to do something, addition or subtraction. Okay, Arely, what do you think?
Can I see the problem one time?
Okay,
One more time?
right here. So here is. So this is rate of change. Bananas are put on the counter. This is rate of change. Bananas are removed from the counter. And this is the question. Is the number of pounds of bananas on the display increasing or decreasing at t equals 5? It's okay.
So,
So what I have to do is this one. This is the number of bananas, correct?
mhm.
So what you have to know is dA, dBT positive or dNB dt negative, correct? So this is increasing and this is decreasing, you know that. This is the calculus, correct? So you need to know one of these. But this is the combination of these two. Now I have to set up add or subtract. What do you think?
You add because one of them is going to be negative, no?
A ver, let's analyze. Como dijo Arely, let's see the problem. Check this out. Is this function positive or negative?
Positive?
Correcto. It's positive until 10. ¿Se fijan? This is positive 10. T is positive because it's between 0 and 12. So this is positive. And sign is positive until this is pi. That's about 10. Possibly more. What about this one? Is positive or negative?
Positive?
Positive, that's correct. Why? Because 3, yeah, is a positive number. 2.4 is positive. And this is more than 3. So in 3, this is 9 plus 6, 15. And the natural log of 15 is positive. So this is positive. So you cannot add them. If you add them, you are adding the bananas they are removing, correct? So what is the positive? What is the negative? From these two.
F is positive, G is negative?
A ver. This is the counter. If you
Yeah.
add bananas is positive.
Yeah.
If you remove bananas is negative.
Yeah.
So which function is this?
F.
No. F
Would
is
have
this one.
F is negative.
This is F. This is G. Correct? G you are putting on. This is replacement. This is removing. So it's negative F plus G. It's very important. If you add them, you are going to get something completely different. Okay, now, important here. dNB of dt is G prime of t minus F prime of t, correct? Everybody catch that? If this is NB, the derivative of NB is the derivative of these two. So it's G prime minus F prime, correct? Okay. Now, I need this one, dNB dt in t equals where? 5? Yeah, t equals 5, correct? So I need g prime of 5 minus f prime of 5. So again, this is going to be in the calculator, correct? Okay, I go to the calculator, right? So right here. And then what I have to do is, okay, g prime, so I have to do this one. Numerical derivative again. So derivative at a point, value 5. Okay. And then I'm going to put here what? G of x minus f of x, correct? G of x minus f of x. So what we replace minus what we remove. Press enter, and we get negative 8822. So this is going to be negative 0.8823. Conclusion. Let's see. No. Is derivative. No, let me see. Let me see. Something is strange here. No. This is really the derivative, sorry. dt. Yeah. So it's going to be really not the derivative, it's just this one. See? So dnb dt in 5 equals to 1. So we don't have to take the derivative. We have to take the number only. Sorry, this is the rate of change. So, yeah, because this is dnbt, this is f minus t, correct. So, vamos a ver otra vez. Let's see. So we're going to do, well, is this one? No, this one really is, not the derivative is g, let me just put it right here, is g of 5 minus f of 5. Yeah. And the presenter, and that's negative. Anyway, it's negative. It's negative 2.2631. So it's negative. So my conclusion is, yeah, ahora sí. My conclusion is what?
It's decreasing.
Correct. The number of bananas at this is the number of pounds is decreasing at t equals 5. Because it's negative, correct? Okie dokie.
Yes.
Okay, last question. Last problem here. How many pounds of bananas are on the display table at time t equals 8? So, oops. So I have this one. So is n of b at 8. So let me just go to my screen. So this is the answer I have to do. What is the number of bananas in the counter at n equals 8? This is, well, remember that the NBT, right? So the NB dt is g of t minus f of t, correct? So we need these ones. So again, we have to integrate. Integrate the NB over dt. dt equals integral of g of t minus f of t vt. Now, the times from 0 through 8, correct? From nb in 0 to nb of 8. Okay? Let me just put this one a little bit more. So the nb of t equals f of t minus g of t. Okay, let me just put it right there. Now, this is simply NB8 minus NB0 is equal this integral from 0 through 8, g of t minus f of t dt. Correct? So this is the number of bananas. The number of bananas at the initial time minus the number of bananas. So how many bananas are on the display at this one? So and well, this is NB of 8 equals NB plus the integral from 0 to 8 g of t minus f of t dt. So this is the number of bananas at time A. This is the number of bananas at 0, right? Oops, there. Correct. So again, we have to do this one. How much is NB of 0? Okay, let me see the problem. The problem is right here. This aquí, it says, it has 50 pounds of bananas on a display table. When certain grocery opens, there are 50 pounds of bananas on the display. So NB of 0 is 50, correct? So this is going to be, let me just put it right here. Yeah. NB of 8 is 50 plus the integral 0.8 g of t minus f of t dt. Now I'm going to use the calculator to get this answer, right? So, and I don't have to do too much. So it's 50. I'm going to put here 50 plus menu calculus integral. So it's 0 through 8 here, parentheses, and I have to do g of x minus f of x. G parentheses x minus f parentheses x dx, correct? So this is exactly the same integral I have here in my board. You see 50, 0, 8 gt minus ft. Okay, so I have again, so gx minus fx, and then press enter. And I have 41.8. So this is going to be 41.844 pounds of bananas, correct? So it's going to be, well, right here, I'm going to write right here, this is 41,844. So it's 41,844 pounds, correct? So this is what we get from our integration. Crazy problems? Yes. But I hope that you notice that pretty much all of them are pretty much the same. You have to find a function that is the derivative. The functions, they give you a rate of changes at the derivative of something. So you have to integrate to get a number of something you have to determine. Then increasing, decreasing is the values of the functions here if its derivative is positive or negative. So not a big deal, but concepts, okay? Everybody fine? Everybody alive? Bueno, ya se fue Brandon, ya se desmayó Brandon. Okay, bueno. Tomorrow, I'm going possibly to do one of these and begin with differential equations, okay? Or you tell me if we continue practicing these ones. I don't know, how do you feel these ones? Difficult?
No mucho.
¿No mucho? Ese es el Leo. Okay,